Okay, so what this leads us to is the first theorem here, which is the extreme value theorem. Right, so the extreme value theorem tells us under which conditions we can expect an extrema. Right, so the condition says this, right? It says that if f is continuous on I, and I is a closed interval, then the conclusion is that f of x has both a min and a maximum. Right, so it's two criteria we got to meet. First one is that f of x must be continuous on I, and the second one is that I must be a closed interval. If we meet these two criteria, then this theorem guarantees that we have two extrema there, right? The first is a min, and the second is a max. Right? And if you look at this diagram over here, right, that confirms it. Because in this case, f is continuous, the interval is closed, and we end up with both a minimum and a maximum. Right? But when any of these conditions are not met, right, then anything can happen. We may have a minimum and a maximum, or we may have a maximum but no minimum, or we may have a minimum but no maximum, right? Or we may have neither. Okay, so make sure you note this one down, extreme value theorem. I'm going to talk about a couple more theorems. So this one I refer to as the EVT. Okay, so let's look at this example here, right? So we have a function f of x equals x squared minus 4x plus 5. And we have a closed interval from -1 to 3. X equals -1 to x equals 3. Right? So first of all, f of x is continuous, right? Polynomials are continuous everywhere. Okay, so that meets the first criteria of the EVT. Right. The second is that we have a closed interval, right? So -1 to 3 is closed. So that meets the second criteria. Right. So now we can conclude that by the extreme value theorem, f of x has a maximum and a minimum on the closed interval -1 to 3. Okay, so does the extreme value theorem make sense? Is it understandable?
It's not close in there. Then. Okay. So would the EVT apply to A on the left side?
Mm-hmm.
Okay.
Right. So scenario A is a case where the two conditions of the EVT are met, and you can see that we have both a minimum and a maximum, right?
Okay.
Right. And in fact, let's say f of x didn't look like this, right? Let's define a new function g of x, and let's say g of x is a straight line, just like I did for the other one, right?
Mm-hmm.
You see that in this case, right, the EVT is still satisfied, right? F is continuous. We still have a closed interval, and we still get the minimum and the maximum. It's just that this time the minimum is over here, right?
Yeah.
However, in scenario B, right, the second part of the EVT is not met, right? The closed interval. So even with the f of x we have, right, we only end up with one extrema, which is the minimum. And if I was to draw that straight line again, that g of x, right, in that case, we have no extrema at all, right?
Mm.